That's the first thing they hear. Okay. H of x. This is just the name of our graph, right? What's the name of my graph? It's just, yes, that it is. I got to do domain. Is this continuous or discrete? So, am I going to do this one or this one? Okay, so less than x, less than. What's my smallest x value? In other words, go all the way to the left. How far do you go? Negative 6. Is it included or not? Okay, so I'll put an equal sign. How far to the right do I get to go? Infinity, because it's an arrow. Range? Less than y, less than? How low does it go? All the way to where?
-5.
-5, okay. Is it included or not?
Yes.
Yes. How high does it go?
5.
5. Included or not? Yeah. Because look, that's point, that's point, that's point, that's point. So we have actually lots of y values of 5. So yes, it's included. We okay with that? Okay, now I'm going to in a different color. If you would like to do it in a different color, it doesn't matter. I'm going to graph now negative h of x. Is that negative an insider or outsider? Outsider. So if it's an outsider, does it impact the x's or the y's? The y's. So what am I expecting it to do to my y values? Think about the table. What do I expect it to do to my y values in the table?
Split the signs, right?
Okay, but in my table, my y values. Negative what? What is h of x? Isn't it also y? So that's like saying negative y. So what would I do to all my y values in the table? What's the negative 1 doing to the y? We'd multiply them all by negative 1, correct? So all the y values would just change signs. Looking at this, it's going to reflect over one axis or the other. Which axis? The x. This right here is what? 1, 2, 3, it's going to become negative 3. This right here we said was negative 5, it's going to become positive 5. This one at the bottom, what is that, negative 4? It's going to become positive 4. And then this line right here that's up here at 5, it's going to come down here. At 5, it looks like it's about right here, and then it's going to go straight across, right? I could use a little bit more information. For example, this point right here, well, that's not going to change, is it? That one's going to stay right there. Do you agree?
Yes.
Okay, so this one we got. What about the y-intercept that's right here? Where will it go? It'll flip up and go to what? 2.5? So if we were to draw these together, this is a big point coming down, making my curve, right? Coming down. This should actually go right through that same y-intercept. I do a very good job of that. What changed, the domain or the range? Is it an outie or any? It's an outie. Does the outie impact the x or the y's? So what changed, the domain or range? The range did. So looking at the range, what is it now? Literally all you have to do is go across the range and you multiply them by a negative 1. I get a 5 over here and a negative 5, which means it'd be what? Negative 5 less than or equal to y less than or equal to 5. Do you agree? Take this, multiply it by negative 1. It ends up there. Take this, multiply it by negative 1. Does that agree with your graph? This is negative 5. This is 5. Okay? We okay with that? Next one, h of negative x. Inside, any or outie? It's an any, so is it going to impact your y's or your x's? So is that going to be horizontal or vertical? Vertical. Okay, so it doesn't tell me to graph it. It says just describe how this is different from that. If I were to graph it, how would I graph it differently? instead of reflecting over the x, it's going to reflect over the So if that's the case, would the domain or range change? Is it an innie or outie? Innie. Does any impact the x's or y's? So if it impacts the x's, what's going to change, the domain or the range? Domain. Looking at all this stuff, so this is some of the new information. By the way, I want to show you another way to write this. Anytime you write these, you also could write it just, it looks like an ordered pair, but it's not. You do a bracket since it's included and do -6, comma, infinity. This is another way of writing that. And the reason I'm going to do that is because you may see it both ways. This one would look like they're both included, so it would be -5 to 5, and it would just be with the bracket. I like that way better if for no other reason, because I get to write less. If it is not included, in other words, it's just a less than sign, you just put parentheses. Okay? We'll try it both ways down below. Here we're going to talk about intervals. So, increasing, looking at this graph, reading left to right, always reading left to right. Where's the graph going up? Think about if you were walking along the graph. When would you be walking up? Left or right? Reading from left to right. Tell me when. In the beginning, so I'd be walking up here until when? Till I get to the top? Okay, so this right here is going up. So that's increasing. When is it increasing anywhere else? After the bottom. So after this point, it starts going up again. Those are both increasing intervals, so we have to write them down. We write them down just like we do domain. You will never write increasing and decreasing with y values. It's always reading left to right. Left to right is always x values. So starting here, what's my x value? So I got -6, and how far is it going to?
3.
-3. I got to put a U for union. It means and. And where else? What's this one? 1 less than x to where?
4.
4. Oops, hold on. I'm out. How come I didn't put included for any of them? They're all part of the graph, aren't they? At this point right here, this particular point, is it increasing? What about this point? Is it increasing? You could just as easily say, if you say it's increasing, couldn't you say it was decreasing? At that point, it's actually changing direction. At this point, it's not doing anything. At this point, it's changing direction. So your ends, when you're talking about increasing and decreasing, they'll never be included. Okay? You could write it that way, or you could write the parenthesis -6 to -3, union 1 to 4. You're used to seeing this more. As you get further in math, this is the way you're going to see it written. It is not a coordinate. It is saying it is increasing from -6 to -3 and from 1 to 4. We okay with that? Let's try decreasing. Looking at the graph, where is it decreasing? Once again, reading from left to right, where do you see the graph going down? In the middle. So starting at this point, it starts going down. So let's figure out over what x interval it's going down. Where does it start going down at? -3 to where?
1.
To 1. So this is how I'd write it in the notation you're used to seeing. Or I could simply write from -3 to 1, it is decreasing. Which way do you like better? This way or that way? Or neither? I I take the one with less letters, less to write. That's my preference. Notice when we're talking about increasing and decreasing, I'm always using parentheses because I'm not going to include any point. At both endpoints, it's going to be changing direction or stopped. Constant, taking a look at your graph. Where is it constant? Yeah, it's a flat line. Anywhere you see that horizontal line is where it's constant. So what's that interval? Where does it start being constant? You're going to have to take a guesstimate because it's kind of in between. Like, say, 3.5. When does it stop being constant?
Never.
It goes to infinity, so never. So if I were to write that in this notation, it would be 3.5, comma, infinity. And that's saying it's constant from here to there. X-intercepts. X-intercepts are where y equals 0. So here's one, and here's one. So I got 3 of them. It's where y equals 0. This one you're going to kind of have to guesstimate because it's falling in between, so it's not going to be perfect. What do we get?
3.5.
4. I would even go as far. It's 1, 2, 3, 4. 4 3/4. 4.75 is fine. Negative 4.75. What about this one? This one's actually pretty. Negative 1, 0. And then the last one, it's about halfway between, so what would it be? 2.5. So x-intercepts every time it crosses the x-axis, so y-intercept is going to be where x is 0. Where does that happen in our graph? We have one place right here. What's that y value about? Negative 2. You want to go with 2.5? That's fine. You've talked about minimums and maximums before. I don't know if you've really talked about local. A maximum is how high it'll go. Minimum is how low it'll go. When you're talking about local minimums and maximums, you're talking about where it's changing direction. It's got to go from increasing to decreasing. So for example, if we're talking about a local min, it's going to have to be here. What you're looking for is the change in direction. You're looking for where it was decreasing, now it's increasing. This would be a local minimum. It's not the absolute minimum because of course the graph does go lower, but it is a local minimum. So we're going to write that as a point. What point is it? 1, negative 4. The maximum works the other way. It's going to go from increasing to decreasing. So you're looking at this point right up here. So what would that point be? Okay. Do you see any other local min or maxes? Would this be one? Why? It was increasing, but then did it start decreasing? No. So unless it goes from increasing to decreasing, or vice versa, it's not gonna be. Any questions about any of that? You all good?